I've written a problem here, and I'm going to go through the whole process of getting it into slope intercept form, identifying the slope and the y-intercept, and graphing that equation. So it's not in y-intercept form, or slope intercept form, excuse me. Slope intercept form, I'm going to cover up the problem, but is going to be y equals some number x plus some number. Y equals mx plus b, where m is the slope. That's how fast things are changing. And b looks like a 6, but b is the y-intercept. It's where it crosses the y-axis, and that's where we start from in most situations. All right, so here's my equation. It is not in that form. To be in slope-intercept form, y needs to be all by itself. It needs to be isolated. So I'm going to do that. There's a couple ways you can do this, and none of them are wrong. So I'm just going to pick one. I'm going to leave y where it is, and I'm going to try and get rid of all the stuff over here by y. So that's the way I'm going to try and isolate y. I'm going to take away 3x over 2, because if you have any big chunk of anything and you take that same chunk away, it always goes to 0. So it doesn't cancel, but it goes to 0. Anything minus itself is 0. I'm not going to write 0. I'm going to do the same thing to both sides of the equal sign, 3x over 2. Now, negative 8 minus 3x over 2, since the 8 does not have an x with it, these are not like terms, so they cannot be combined. You could write negative 8 minus 3x over 2, just the way it sits right here, and just rewrite it. And that would be fine. It'd be correct, but it wouldn't be as helpful to us. To be in slope-intercept form, we typically, not always, but we typically like to have the slope first. Have some number x plus some number in that order. So I'm going to rewrite it in that order. I'm going to write negative 3x over 2 first, and then I'm going to write the minus 8. Again, algebraically, there's nothing wrong with putting the minus 8 first and the 3x over 2 second. However, it just wouldn't be in that form that we like so much. So I rearranged it to put it closer to this form. All right, I'm almost there. Now I have to get rid of this minus 2. Don't forget, if there's a minus here, that minus sign is like a negative 2. You could always change it to plus negative 2 if you really wanted to. And so that minus sign stays with the 2. Don't forget to carry that down with it. I'm going to divide both sides by negative 2. Ooh, this is going to be tricky just in the way I write this. So maybe what I'll do is I'm going to put parentheses here. I'm going to put divided by negative 2. Because if I put over negative 2, I've got fractions inside of fractions, and that just looks messy. On the left side, anything divided by itself is 1. Negative 2 divided by negative 2 is 1. So I have 1y left over. There it is. I can see it, 1y. And now I've got this stuff over here. Minus 8 divided by minus 2, negative 8 divided by negative 2, that's going to be a positive 4. So I can get that right away. Negative 3 halves x divided by negative 2, that just sounds like a lot of work. So maybe another way to think about it, and I'm going to do a little bit of scratch work. Maybe I'll do it up here. So this is scratch work. If I asked what is 1/2 divided by 2, think about it with money. You know, half a dollar, that'd be like 50 cents. And 50 cents divided by 2, that would be a quarter. That'd be one quarter, 25 cents. So a half divided by 2 is a fourth. Again, 50 cents divided by 2. If I break it into 2 piles, I get a quarter. Going back down here then, a half, here's my divided by 2, 3 halves divided by 2 is going to be 3/4. If I have 3 groups of 50 cents, 3 halves, I divide them all up into 2 piles, I get quarters, 3/4. You can do the full math, you can take reciprocals, and you can do all the algebra in there, but it works out that we have 3/4, and a negative divided by a negative is positive. So we got 3/4 or 3x over 4 plus 4. That's really close to what I have up here. The only difference is it's not written as a number times x. It's written as a number times x divided by another number. And when that happens, without getting into too much of the nitty-gritty of how this is true and why, we can rewrite that as 3/4 x plus 4. So it feels like you're just pulling the x off to the side. And that's kind of what it looks like. There's some legitimate math behind why that works and why you can always do that, but you can just kind of plop it off to the side. All right, now we have an equation, 3/4 x plus 4, and it's written in slope intercept form right there. So now I'm going to graph it. All right, y equals 3/4 x plus 4. That was my my equation in slope intercept form. The y-intercept, where I'm starting from 4. It crosses the y-axis. This is the vertical y-axis at +4. If that was a -4, it would cross the y-axis at -4. There's my starting point. The slope tells us how fast we're changing. Slope is the change in y over the change in x. That's what slope represents. Triangle in this case means change, which means that from my starting point, I'm going to change 3 in the y. And it's a positive number, so I'm going to change +3 in the y. I'm going to go up 3. 1, 2, 3. The x change, the change in x is 4. So I changed in y 3. I'm going to change in y in x 4. 1, 2, 3, 4. Again, it was a positive. So there's my next point. Once you have 2 points, you can really connect the dots and make a line, but you could also keep going. 1, 2, 3, change in y. 1, 2, 3, 4, change in x. And you'll see that I'm still on that same line. You can go backwards too. 1, 2, 3, 1, 2, 3, 4. And we should end up with, no, there we go. Sorry. 1, 2, 3, 4, 1, 2, that looked wrong. There we go. And my drawing straight skills are not perfect, but you get the idea. That's how you graph this fraction of a slope with that y-intercept. Hope that helps.